Okay, so obviously the hardest part is the signage in this situation, um, and so I'm just going to start with my convention saying that everything moving in that direction, and that's I'm actually sort of assuming this whole system works horizontally, it's sort of as a rectilinear sort of situation. So I'm going to say that's positive and that's negative. Now, the key thing with this question is figuring out which way the system is moving. Now, if we're talking about the minimum value for m, everything up to that minimum value is going to move in this direction. So that's the key concept to grab here. So that there's a driving force pulling this down, and that's what everything else is resisting up till m equals 10 kilograms, and then it's not going right or left. It's obviously going to be completely balanced, but up till m equals 10 kilograms, the system wants to move to the left, and all the forces of friction resist that motion. So we've got that driving force, which is a negative driving force because it's going towards the left, equal to m1 g sine theta. And obviously there is a resisting force from the other mass, which I'm doing red here, going this direction, and that is m2 g sine theta. Now, friction in this case, because you've got to remember this whole idea of the whole system wanting to go in that direction. So friction always opposes the motion. So we're going to have a friction force in this direction, which is mu mg cos theta. Should have written m1, but you get the idea. And friction is still opposing the motion, which is in this direction. So he is mu m2g cos theta. So you can see only the green force here is the positive, sorry, is the negative one. Everything else is positive because they're all going towards the right. So what I end up with is a net force equal to 0, and all the forces are negative m1. Actually, I'll do it in green, make this nice and clear. You can see what our forces are. m1 negative m1g sine theta plus mu mg cos theta plus m2g sine theta plus mu m2g cos theta. So that's how they all work. Now, if and I did adapt this question from what I'd seen previously in a university textbook, which was find the maximum and minimum values that could hold equilibrium. So if we were going to find the maximum value, it all just becomes about thinking about which direction the system's going. So in that case, and what I'll do is I'll just quickly erase all this so we're not confusing ourselves. If we were looking for the maximum value now, okay, so now we got to get rid of that guy. So the maximum value means that the driving force for this will be this guy here. So he's going to be the driving force, m2g sine theta. And that means the whole system now is going to start going in that direction. So friction is going to oppose that. So we're going to get some friction in that direction. That's obviously going to have a force of gravity that's parallel and some friction that's also going in that direction. Cool. So yeah, it's just all about thinking about which direction the system goes and having a notation for the right or to the left, and then ensuring you've got your frictions opposing the direction of motion. Hope that makes sense, mate. Let me know if you have any other dramas.